Today we're going to be looking at how we can write equations that represent linear functions or linear relationships. So for this first example, we're going to be given a graph. Yesterday we looked at graphs and we were able to determine the slope of the line that was given to us. So now we want to be able to write the whole equation. And the whole equation for a linear function or a linear equation does involve finding the slope. So what you did yesterday is going to be needed in order to do what we're doing today. So if you weren't proficient at finding the slope given a graph, then you might want to go back and revisit that. So linear equations are written only in the form y is equal to mx plus b. Okay, so this is only for linear equations, where m is your slope, right? That's what we found yesterday, and b is your y-intercept. So that's where your line crosses your y-axis. Okay, so again, this is your rate of change or your slope or the steepness of your line. Lots of different ways to think about slope, right? And your y-intercept, we also call that the initial value, the starting value. So lots of different ways to think about this. This is your value when your x is equal to 0, right? So we need both of these two things to write our full equation. So yesterday we found m, right? So if, let's say we were able to identify these 2 points on our graph or on our line, that the point 2, 2 and the point 4, 3. And that should have been up more. 1, 2, 3. Yep, 4, 3. So let's say on our line we are able to identify these nice 2 points with integer coordinates. So we can find our slope by finding the rise over run between them, the vertical distance between them over the horizontal distance between them. So this was 1 and this is 2. So our m, the slope of the line between these 2 points, has a slope of 1/2, and that's going to be positive 1/2 because the line has a positive slope. So now what is our b, our y-intercept? Well, again, remember b is where your line crosses your y-axis. So this is our y-axis here. It's our vertical axis. And it crosses our y-axis right here. So that's going to be our b, and that has a value of 1. So the equation for this line is going to be y is equal to 1/2 x plus 1. That's going to be the equation for this line, right? It has a slope of 1/2, positive 1/2, and a y-intercept of 1. Let's take a look at a second example. So here we are in the 4th quadrant of our coordinate plane, right? These are positive x values and these are negative y values, okay? And this is your origin. I just don't want you to get confused. So again, let's say we're given this line and we are able to identify 2 nice points on our line. Let's say that this is the point 0, -4. Oh, my marker's running out. 0, -4. And let's say that this is the point 5, -6. And we were able to identify that by looking at our graph, right, and identifying really nice ordered pairs that have integer coordinates. So again, we're going to find our slope, right? We need both of our slope and our y-intercept. So here, the rise, the vertical distance between these 2 points, over our run, the horizontal distance between these 2 points. So our vertical distance is 2, our horizontal distance is 5, and this has a negative slope. So I'm going to say that my m is going to be equal to negative rise over run. So that's -2/5. That's the slope of my line. My y-intercept, again, that is where our graph crosses our y-axis. And here, this is our y-axis, right? Our vertical axis. So I know that my b, my y-intercept, is going to be here, right at -4. And in fact, that was one of the points that we used. So our b is going to be -4. So the whole equation for this line will be y equals m, which we said was -2/5, x, and I'm going to put parentheses around that just to make it easier to see that this is multiplication, negative 2/5 x plus negative 4. So I can change this plus negative 4 into just subtraction. So I'm going to go ahead and rewrite this equation. Y is equal to negative 2/5 x minus 4. So this would be the final equation for this line, this linear function.